I'm just going to show you how you get these ions that form these compounds A and B. Now these are double displacement reactions, which means that what we're going to do is, so we have AgNO3 and FeBr3. What's going to happen is that the cation of one will join with the anion of the other, and the cation of this one will join with the anion of the other one. It's kind of like an insides and outsides. The other way you can think about it is you can look at this as two couples dancing and then they switch partners. Sort of what's going on with these double displacement reactions. Now, in order to be successful in figuring out the charges of everything so that you can get the compounds for A and B, here's what you're going to have to do. I would recommend drawing out the compounds, making sure you realize how many of each ion you actually have in each compound. So here we've got one silver and one NO3. Now remember, this is a polyatomic ion. There's not three NOs here. The 3 is with the oxygen, but we only have one NO3 group. If there happened to be more than one NO3, like in this compound, it would have been denoted by having parentheses and a number outside the parentheses. That would indeed have two NO3s, for example. But this one, AgNO3, only has one NO3 unit. Alright, let me get rid of that. Okay, so that's how we figure out how many of those we've got. Now let's look at the FeBr3. Now with the FeBr3, we've got Fe and then 3 separate Brs. Now what's the difference between this and this? Well, this was a single polyatomic ion, one unit of NO3. This here is a single element ion, and we're trying to say that there's actually 3 separate Brs right here. Now in order to figure out the charges, what we're going to have to do is say we've got silver and nitrate. Now we know NO3 has a -1 charge. We can get that off the polyatomic ion sheet. Now if we're going to end up getting a match on the silver, that's going to be a total of -1. That's going to be a total of +1 to match that. So the silver then has to be a positive charge. So we know that the silver will have an Ag, will be Ag+. We know that NO3 will form a -1 charge. And then over here we've got the Brs. Now each Br is a -1 because they're in group 7, and we can get that off the periodic chart. That's a total of -3 right there. That means we need a total of 3 positive charges to balance that out, which means the ion will have to have a 3+ charge. Alright, so now you can see what the ions are for this one. This one will be Fe3+. And remember, we're only interested in one of these, and that's going to be the Br negative. So those are the answers to each of those. I'm going to take this one step further and show you how these join together. So what we're going to do is we're going to join this together. We're going to have an Ag+ joining with the Br-, and then we'll have the Fe3+ joining with the NO3-. And that's going to form compound A, and this one's going to form compound B. So let's see how that goes. Now I'll just rewrite this again. So AgNO3 plus FeBr3 would give Ag+ and Br-. Well, there's just one of each of those, so that's just going to join together to form AgBr. And here we've got Fe3+ and NO3-. And the question I'm asking there is, how many of these NO3- do I need to balance out the 3+? And that would be Fe, and I'd need 3 NO3s. And that would, and then that would balance that compound up there. And if I wanted to continue on with this, I would balance out the actual reaction. And you see I've got 1 Ag, 1 Ag. I've got 1 Fe, 1 Fe. I've got 1 NO3 and 3 over here, so I'll put a 3 in front of the AgNO3. That means I need a 3 in front of the AgBr. That gives me 3 silvers, but it also gives me 3 Brs, which balances these 3 Brs here. And then if I look at the solubility chart, I'll see that that's the solid, and that these guys are aqueous. And that would at least complete that part of the question, which involves figuring out the compounds here, and then later on you could split this into ions as well. But at least that gets you this far.